Hey there, Fundamentals here, back for another magic internet math video. This one's also by special request. And we are going to talk about primes. Okay, we've all heard prime numbers are very special. I'm sure we've all heard it somewhere. I once heard that it should be the human race's primary mission, no pun intended, to be searching for the largest prime number on Earth. And I heard this in the context of somebody saying, this will demonstrate to the aliens that we're smart. Okay, that's kind of cool. Let's talk about what the heck is a prime number. Why are they cool? Why do they matter? And how do we figure them out? All right. So a prime number is a number. It's an integer. We like to call it P. We like to name things that have usually the first letter of the word that we're trying to describe. So we have an integer. We call it P. And we have this notion of a divisor, and maybe whoever asked for this video is also going to ask, what is a divisor? And maybe I'll do that one as well. A divisor is a number that divides into another number. So if I had a number 10, the divisors would be 1, 5, 2, and 10. I should have gone in order, 1, 2, 5, and 10. So 10 is not a prime number. In fact, no even number outside of the number 2 is a prime number. But 2 is prime because the only numbers that can divide 2 are 1 and 2. So we have some numbers that we know are prime. 2, 3, not 4, because that's 2 times 2. 5, yes, and then none of the even numbers, etc. But I'm just gonna show you a very cool way to find prime numbers. It's called the sieve of Eratosthenes, and it works. Let's say it works on if you're looking at like the numbers 1 to 100. This will be nice and low effort. If you try to do this from 1 to 1,000, maybe it's a fun afternoon, but it's going to be very tedious, and you'll need a lot more paper than this. If you're going to try to do it up to 10,000, good luck. It might take you a few days. But we're going to show you how a sieve works. And if you ever study computer science, really in any way, you're going to learn a number of sieve methods for determining not definitely prime numbers, but like what are good candidates for prime numbers. Because when you go off this page and you get into these numbers like 1,001, your brain, we just don't have a good intuition for whether it's prime or not. So what you hope for is a likely candidate for a prime number, but it's actually very difficult outside of doing the actual factoring, it's very difficult to demonstrate a number is actually prime. So you have primality tests and you have sieves. And I'm going to show you a very simple sieve. Now, the sieve of Eratosthenes. So we take all the numbers 1 to 100. Now, 1 is not prime, so we don't worry about that. Okay. Now, I'm going to start writing down numbers that I know are prime. So 2. I know 2 is prime, so I will circle 2. And now what I'm going to do is I'm going to cross off every multiple of 2, because every multiple of 2 is not prime. So boop, boop, boop. I'm going to just cross off every multiple of 2. Hope I don't make a mistake and have to do this whole thing over again. There is actually a really good presentation. There's on Wolfram Alpha. I would definitely recommend checking out Wolfram Alpha. If you go there and you check out Sieve of Eratosthenes, they have a very slick visual way of doing what I'm doing. What I'm doing is really tedious and boring, which I'm sure makes for a great YouTube video. But I really want to just, demonstrate really what prime numbers are. and how you find them. So we've got 2, and we've gotten rid of all the multiples of 2. And now, what's my next prime number here? 3. 3 is definitely my next prime number. Okay? So now I'm going to do the same thing I just did, and I'm going to now cross off all of the odd multiples of 3. So goodbye 9, goodbye 15, goodbye 21, 27. Once again, really hope I don't mess this up and have to do this all over again. But do you know that how you know a number is divisible by 3 is that if the 2 digits add up to a number, that's divisible by 3. So 5 plus 1 is 6, so we know that's divisible by 3. Thought that would be a fun fact. So a little pattern emerging here. So we are getting rid of all of the odd primes divisible by 3. 81 is 3 to the 4th power, so we definitely know that is. 99, and then 93. Very good. Okay. 4 is gone, but look, we got 5. 5 is the next. So 5 is the next number we haven't crossed off. So basically what we're saying is that when you go to the next number, if it hasn't been crossed off, it's prime. Okay? We happen to know 3 was prime. We happen to know 5 is prime, but this sieve is now telling us 5 is prime. Now this will be a very easy one to cross off. So all the numbers ending in 5, and then all the numbers, we already got the numbers ending in 0. Okay, so now what's my next number? Put commas in here. My next prime number is 7. Okay, let us get rid of all of the multiples of 7, and there aren't going to be too many in terms of odd multiples, because most of them have already been crossed off. But 49, 7 squared, that one is still here. 77, which is 7 times 11. Bye-bye to you. And that is, and 91. 7 times 13. Okay, so now what's our next prime? 11. So do we have any multiples of 11 still lingering around? I don't believe we do. Okay, I'll write that. 13. Do we have any multiples of 13 hanging around here? I don't think so. In fact, the trick is once you've crossed the square root of your highest number, right, and the square root of 100 is 10. So once you've crossed the square root of your highest number, 10, you're done. Isn't that cool? So now I know that the remaining numbers here are all prime. How cool is that? Prove me wrong. I should put some Bitcoin bounties in these videos. If I say prove me wrong and you do so, I'll think about a bounty program for anyone who actually does. But there you go. That's the sieve of Eratosthenes, and that is the way, essentially, you would want to find prime numbers. Now, why are prime numbers really important? The best thing I can say, what are they used for? They're used in cryptography very prominently. Best thing I can say is a prime number is just something that can't be broken down any further, and there's a lot of value in knowing you are dividing by something that can't be divided any further. I think in the next video I'll get into relatively prime. What is that and what does that mean? And I think we'll end it here.